Our objectives in this lesson are the following. Illustrate the measures of variability. These are range, interquartile range, average deviation, variance, and standard deviation. And calculate these measures of variability for group data. Let's have a quick review. Measures of variability are descriptive measures that indicate the degree of spread or dispersion among the values in the distribution and from the center of the dataset. As mentioned earlier, these are the following. Let's have an example. The security guard recorded the age from the contact tracing form of the first 30 people who visited the drugstore, and he constructed a frequency table for this. These are the range of the ages, and these are the corresponding number of people. If you would like to know how to construct a frequency table, review our lesson on frequency distribution table. Let's have the first measure of variability, the range, denoted by capital R. It is the difference between the highest class boundary and the lowest class boundary. In formula, where R is the range, UCBHI is the upper class boundary of the highest interval. LCBLI is the lower class boundary of the lowest interval. In interpreting the range, the higher the range, the greater the spread of values. Let us recall our table earlier. To solve for the range, we need to determine the class boundaries. But we are only going to determine the class boundaries of the lowest class interval and the highest class interval. To determine the class boundaries, we just have to subtract and add zero point 0.5 to the lower class limit and upper class limit respectively. 63 minus zero point 0.5 is 62.5. 71 plus zero point 0.5 is 71.5. So the class boundary is 62.5 to 71.5. Now for the lowest class interval, 18 minus zero point 0.5 is 17.5 and 26 plus zero point 0.5 is 26.5. Therefore, the class boundary is 17.5 to 26.5. Now, let us recall the formula for the range. The upper class boundary of the highest interval. Let us look at the highest interval. By the way, this frequency table is arranged in descending order. Later, I will have an example of a frequency table arranged in ascending order. Again, let us look first at the highest interval, and that is 63 to 71. The upper class boundary is 71.5. Now, for the lowest interval, this one, 18 to 26, the lower class boundary is 17.5. 71.5 minus 17.5 will give us a range of 54. Just a recall, this on the left side is the lower class boundaries and this on the right side is the upper class boundary. The next measure of variability is the interquartile range. This measures the amount of dispersion present in the middle 50% of a data set. It is the distance between the first quartile and the third quartile. You have learned from our previous lesson the formula of IQR is equal to Q sub 3 minus Q sub 1, where Q sub 3 is the third quartile. It is the median of the data points to the right of the median in the ordered list. And for Q sub 1, this is the first quartile. It is the median of the data points to the left of the median in the order list. Now, how do we determine quartiles for group data? We need this formula, where Q sub k is the kth quartile class. L sub Q sub k is the lower class boundary of the kth quartile class. N is the total frequency. Less than CF is the less than cumulative frequency of the class previous to the kth quartile class. F is the frequency of the kth quartile class, and I is the class width. But before we determine the quartile, we have to determine first the quartile class. Let us recall our frequency table. And now we are going to add some column to this. We have the class boundaries and the less than cumulative frequency. For the class boundaries, again, you just have to subtract 0.5 from the lower limit and add 0.5 to the upper limit. So again, this is 62.5 to 71.5. This will become 53.5 to 62.5. This one is 44.5 to 53.5. This is 35.5 to 44.5. This one is 26.5 to 35.5. And this one is 17.5 to 26.5. Now, for the less than cumulative frequency, we always start at the lowest class limit. So here, the frequency is 6. We just have to copy it. And then we're going to add the next frequency. 6 plus 5 is equal to 11. 11 plus 4 is equal to 15. 15 plus 5 is 20. 20 plus 7 is 27. And 27 plus 3 is equal to 30. Now, let us have the formula for the quartile class. So we have k times n divided by 4. This is the value of the quartile class we are going to look for. K here could be 1, 2, or 3. That represents first, second, and third quartile respectively. Let us determine the first quartile. Since this is the first quartile, our k is 1. N is the total frequency, and that is 30. And then divided by 4. Why 4? Because quartile divides any distribution into 4 equal parts. Now, what is the value? 1 times 30 is 30, divided by 4 is 7.5. So we are looking for the 7.5th value. The next step is to look for the cumulative frequency that is greater than or equal to 7.5. There is no 7.5 here. The first greater than 7.5 value is 11. Therefore, our first quartile is the class from 27 to 35. This is our first quartile class. Now, let us solve for the third quartile class. So we have 3 because we are looking for the third quartile class. So k is also equal to 3. Again, n is the total frequency, and that is 30, divided by the constant 4. 3 times 30 is 90. 90 divided by 4, we are looking for 22.5th value. There is no 22.5 here, and the first cumulative frequency greater than 22.5 is 27. So the third quartile class is the 54 to 62. This is our third quartile class. Now that we already know the first and third quartile classes, we can now solve for its value. Let us recall the formula. Let us solve first for the first quartile. Here is our formula. This is the lower class boundary of the quartile class. Since we are looking for Q sub 1, the lower class boundary that we are going to consider is 26.5. Our K again is 1 because this is first quartile. Our N is 30 divided by 4 minus the less than cumulative frequency. Less than cumulative frequency is the less than cumulative frequency of the class previous to the quartile class. So if this is the first quartile class, the less than cumulative frequency previously to it is 6. So we're going to substitute 6 for the less than cumulative frequency here. Then this one is the frequency of the quartile class. The frequency of the quartile class is 5. I here is the class width. To determine that, you just have to subtract two succeeding lower class limits or upper class limits. For instance, 27 minus 18 is equal to 9. If you want the upper limit, 35 minus 26 is also equal to 9. You can do that for any class limits here. Let us say 63 minus 54 is also 9. 71 minus 62 is also 9. Now that we already know all the values of this, let us substitute them in the formula. Again, 26.5 is the lower class boundary of the quartile class. 1 here stands for the first quartile. 30 again is the total frequency. And then divided by the constant 4. Then 6 here is the less than cumulative frequency of the class previous to the quartile class. If this is the quartile class, the class previous to it is this one. So the less than cumulative frequency is 6. Divided by the frequency of the quartile class, which is 5, times I, which is the class width. Again, for the class width, we simply subtract two consecutive lower limits or upper limits. 35 minus 26 is equal to 9. Now, when you compute, make sure to be extra careful. You perform first the one inside this bracket. 1 times 30 is 30 divided by 4 is 7.5 minus 6 is 1.5 divided by 5 is 0.3 times 9 is 2.7 plus 26.5 will give you an answer of 29.2. Now, how do we interpret this one? Since this is the first quartile, it means 25% of people who visited the drugstore is less than or equal to 29.2 years old. Now let us solve for the third quartile. Let me substitute the given and let me explain how did we arrive with this. 53.5 is the lower class boundary of third quartile class. Here, 3 stands for the third quartile. 30 again is the total frequency divided by the constant 4 minus 20. Why 20? This is the less than cumulative frequency of the class previous to the third quartile class. This is the third quartile class. Previous to it is this class, and the less than cumulative frequency is 20. Divided by 7 here is the frequency of the third quartile class. Here, 7 times, again, the class width, which is 9. So when you compute this, is start at the innermost. Multiply 3 times 30, and then divided by 4. Subtract 20, and then divided by 7. Then multiply to 9, and then add 53.5. This should give you an answer of 56.71. Let us interpret this. Since this is the third quartile, it means 75% of people who visited the drugstore is less than or equal to 56.71 years old. Now, finally, let us compute for the interquartile range. The IQR is Q sub 3 minus Q sub 1. So that will be 56.71 minus 29.2. And this is 27.51. The next measure of variability is the average deviation. It measures the average value by which any value in a distribution deviates from the mean of a data set. We have two formulas. This one is for the sample average deviation, and this one is for the population average deviation. Somewhat similar though, where AD is the average deviation, X here is the class mark or midpoint, X bar or mu is the mean, small and capital letter N is the total frequency, And then we have here the summation of f multiplied by the difference of x minus x bar. This is the sum of the products of the frequency and the difference between the midpoint and the mean. Let us recall again our frequency table. We are going to add columns to this one. Now we have x for class mark or midpoint, and then we have f times x, the product of these two columns. And then we have the absolute value of the midpoint minus the mean. And for the final column, we have the product of the frequency and the absolute value of the midpoint minus the mean. So let us start with the first row. To determine the class midpoint or class mark, simply add the two limits, 63 plus 71, and then divided by 2. And that will give us 67. 54 plus 62 divided by 2 will give us 58. 45 plus 53 divided by 2 will give us 49. 36 plus 44 all over 2 will give us 40. 27 plus 35 all over 2 will give us 31. 18 plus 26 is 44 divided by 2 will give us 22. Now let us solve for f times x. So we just have to multiply these two columns. 3 times 67 is 201. 7 times 58 is 406. 5 times 49 is 245. 4 times 40 is 160. 5 times 31 is 155. And 6 times 22 is 132. Then let us get the sum of this, and this will give us 1,299. To solve this column, we have to determine first the mean of our distribution. And it has a formula of the summation of fx divided by n. We already have the summation of fx, that would be 1,299. And our n is equal to 30. 1,299 divided by 30 is 43.3. Let us start with the first row. Our x is 67 and our x bar, the mean, is 43.3. 67 minus 43.3 is 23.7. 58 minus 43.3 is 14.7. 49 minus 43.3 is 5.7. 40 minus 43.3 is negative 3.3, but we are asked to get the absolute value, so positive 3.3. 31 minus 43.3 is negative 12.3, absolute value, positive 12.3. 22 minus 43.3 is negative 21.3, absolute value, positive 21.3. Now, for the last column, we simply have to multiply the frequency and our answer here. So we have 3 times 23.7 is 71.1. 7 times 14.7 is 102.9. 5 times 5.7 is 28.5. 4 times 3.3 is 13.2. 5 times 12.3 is 61.5. And 6 times 21.3 is 127.8. And then let us sum this up, and it will give us 405. Let us now solve for the average deviation. Let us recall the formula. So the numerator here is this one, 405, and our n is equal to 30. 405 divided by 30, the average deviation is equal to 13.5. The next measure of variability is the variance. It is the average of the square difference from the mean. It measures the dispersion of a data set. It indicates on average how far is each value in a data set is spread out. Again, we have two formulas. This one is for the sample variance, and this one is for the population variance, where S squared and sigma squared is the variance. X here is the class mark or midpoint. Then we have here the sum of the products of the frequency and the squared deviation. X bar and mu is the mean, and small and capital N is the total number of values. So, how do we interpret again the variance? High variance means the data points are more spread out from the mean and from each other. Let us recall our frequency table earlier, but we are going to add some more columns to this one. We have here the x minus x bar, and then the square of the x minus x bar, and then the product of the square of x minus x bar and the frequency. Earlier, we already solved for x bar, and that is equal to 43.3. Let us start with the first row. Our x from this column, 67, minus the x bar is 43.3. So 67 minus 43.3 is 23.7. Whatever is our answer in this column, we simply have to square for this column. 23.7 squared will give us 561.69. And then whatever is our answer here, we simply multiply with its corresponding frequency. So 3 times 561.69 is 1,685.07. Next row, our x is 58 minus 43.3 is 14.7. Square of it is 216.09 multiplied to its corresponding frequency, which is 7, 1,512.63. Next, our x is 49 minus 43.3 is 5.7. Square that, and that is 32.49. Multiply to its corresponding frequency, which is 5, is 162.45. Next, our x is 40 minus 43.3 is negative 3.3. Take note, in average deviation, we'll look for the absolute value of x minus x bar. But for variance, we simply get x minus x bar. No need for the absolute value. So we have negative 3.3. When you square that, that is still positive 10.89. Multiplied to its corresponding frequency, which is 4, is 43.56. Next, our x is 31 minus 43.3 is negative 12.3. Square that, 151.29. Multiply this to the corresponding frequency, which is 5. That will give you 756.45. Last one, our x is 22 minus 43.3 is negative 21.3. Square this, 453.69. Multiply to its corresponding frequency. This is 2,722.14. Now let us get the sum of this, 6,882.3. Let us now solve for the variance. Let us recall the formula. So the numerator, we already have that, this one. So s squared is equal to 6,882.3. Our n again is 30 minus 1. So we have 6,882.3 divided by 29 is 237.32. So this is the variance. Last measure of variability is the standard deviation. It is simply the square root of the variance. It measures on average how far each value in a data set is from the mean. It is considered the most important measure of variability. Once again, we have two formulas. This is for the sample standard deviation, and this one is for the population is standard deviation, where S and sigma is the standard deviation, X is the class mark or midpoint, X bar and mu are the mean of sample and population respectively. Small and capital N is the total number of values. And this one is the sum of the products of the frequency and the squared deviation. To interpret standard deviation, high standard deviation means that the data points are more spread out from the mean. So let us solve for the standard deviation. We use sample standard deviation because our scenario is the first 30 people who entered the drugstore. Earlier, we have solved for the sample variance, and that is equal to 237.32. To solve for the standard deviation, we simply have to get the square root. So this is square root and this exponent 2 here will simply cancel out. And the square root of 237.32 is 15.41. Let us recall our mean, and that is 43.3. So what does this mean? It means that the ages are clustered within 15.41 around the mean. So that is in between 27.89 and 58.71. How did we arrive with these values? 43.3 minus 15.41 is 27.89. 43.3 plus 15.41 is 58.71. For the summary, here are the things that we discussed in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. We are asked to solve for the range, the interquartile range, average deviation, variance, and standard deviation. On the right is the frequency distribution of the minutes spent listening to the music of 50 students during their free time. So here, the frequency table is arranged in ascending order. In my example earlier, it is arranged in descending order. So let us first solve for the range. Let us recall the formula. So range is equal to the upper class boundary of the highest interval. Highest interval, so that would be 77 to 83. And the upper class boundary, that would be 83 plus zero point 0.5 is 83.5. This one is the lower class boundary of the lowest interval. This is the lowest interval, and the lower class boundary is 28 minus zero point 0.5. So that is 27.5. So again, for the upper class boundary of the highest interval, that would be 83.5. And then lower class boundary of the lowest interval is 27.5. 83.5 minus 27.5 is equal to 56. Next one, the interquartile range. Determine first the quartile class. And for that, we are going to use this formula. This is 1 because we are going to determine the first quartile class. K is also 1, again because this is 1. Our N is 50, that is the total frequency, divided by 4. 1 times 50 is 50 divided by 4. We are looking for the 12.5th value. Let us look at the less than cumulative frequency column. Is there 12.5? None. The next higher less than cumulative frequency to 12.5 is 14. Therefore, this is our first quartile class, Q sub 1. Now, let us determine the third quartile class. So, for the third quartile class, our K is 3. And then N again is 50 divided by 4. 3 times 50 is 150 divided by 4. We are looking for the 37.5th value. Take a look at the less than cumulative frequency column. Is there 37.5? None. The next higher to it is 40. Therefore, this is our third quartile class, Q sub 3. Now that we already know Q sub 1 and Q sub 3, we can compute for its value. For the first quartile, we need this formula. Q sub 1 is equal to 41.5. How come? Because this is the lower class boundary of the first quartile class. This is 42. 42 minus 0.5 is 41.5. Next, this is 1 because first quartile. This is our n, 50, divided by 4. Now, y minus 8, because this is the less than cumulative frequency previous to the first quartile class. Take note, previous, since this is arranged in ascending order. So, the class previous to first quartile class is this one. And the less than cumulative frequency of it is equal to 8. So we have here 8. All over, this is the frequency of the quartile class, and that is 6. Now, how did we get 7 here? You simply subtract 2 consecutive lower limits or 2 consecutive upper limits. 41 minus 34 is 7. If you want the lower limit, 35 minus 28 is still 7. 1 times 50 divided by 4, then minus 8, and then divided by 6, multiply that to 7, and then you add 41.5. It should give you 46.75. Now, how do we interpret this one? Since this is the first quartile, it means that 25% of the students is spent less than or equal to 46.75 minutes listening to music during their free time. Now, let us solve for the third quartile. So, where did 62.5 come from? It is the lower class boundary of the third quartile class. 63 minus 0.5 is 62.5. This is 3 because this is the third quartile class. And then 50 is the total frequency divided by the constant 4. Then y33. This is the less than cumulative frequency of the class previous to the third quartile class. So the class previous to the third quartile class is this one. And the less than cumulative frequency is 33. All over, 7 is the frequency of the quartile class. We have here 7. Multiply with the class width, which is also 7. So 3 times 50 divided by 4, then subtract 33, and then divided by 7, then multiply the answer by 7, and finally add 62.5. It should give you an answer of 67. Now that we already know the values of the first and the third quartiles, we can now solve for the interquartile range. Q sub 3 minus Q sub 1. 67 minus 46.75. And this is equal to 20.25. The next one is the average deviation. So we need these additional columns. So let us start with the midpoint. How do we solve this again? You simply add the two limits. 28 plus 32 all over 2. So 28 plus 34 is 62. Divided by 2 is 31. Do that for the rest. That would be your midpoint. So 77 plus 83 and then divided by 2 will give you an 80. Now for fx, simply multiply these two columns here. So 2 times 31 is 62. Do the same thing for the rest of the rows. And then you get the sum, 2,803. Now, to solve for this column, we need to identify first the mean. And once again, the formula is the summation of fx over n. Summation of fx is this one, 2,803 divided by our n, which is 50. And this is 56.06. To solve for the deviation, absolute value of the deviation, that would be the x31 minus the mean 56.06, and that is negative 25.06. But we need to get the absolute value, so that is positive 25.06. Do the same thing for the rest of the rows. Again, x 38 minus 56.06. That is negative 18.06, but you need to get the absolute value. That's why we have positive here. Now, for the last column, your answer in the deviation column, multiply it with the corresponding frequency. 2 times 25.06 is 50.12. 6 times 18.06 is 108.36. Do the same thing for the rest of the rows, and then finally get the summation. Now, let us substitute it to the formula. Our numerator is the summation here, 547.12 divided by our n, which is 50. 547.12 divided by 50 is 10.94. So this is the average deviation. Next measure of variability is the variance. For the variance, we need these three additional columns. And since we already computed for the mean, to solve for the deviation, that would be x31 minus 56.06 is negative 25.06. It's okay to have negative answers here because we are not looking for the absolute value, just the answer. So another example, 38 minus 56.06 is negative 18.06. Do that for the rest of the rows. Now, for the d squared, we simply have to square this column. 25.06 squared is 628. Even though these are negative, when you square that, that will become positive. And for the last column, your answer for d squared, simply multiply to the corresponding frequency. Sample 2 times 628 is 1,256. Do the same for the rest of the rows. And finally, you get the sum. And now let us solve for the variance. Again, I use sample variance because nothing is mentioned in the situation that 50 is the population. For the numerator, that is 8,338.82, and n minus 1 is 50 minus 1. This will give you 170.18. The last one is the standard deviation, and this is just the square root of the variance that we solved earlier. Take the square root. This will be cancelled out. Square root of 170.18 is 13.05. Recall that our mean is 56.06. So this means the minutes spent listening to music are clustered within 13.05 around the mean. That is between 43.01 and 69.11 minutes. Gets? I hope you can subscribe to my channel, like this video, and share it as well.